Welcome back to Programming with C++. Last day is week 5 of Programming with C++. In this section, we'll be talking about iterative statements, learning the various types of iterative statements, practicing on using iterative statements. Okay, so now let's proceed. So when we talk about iterative statements, they are commonly known as loops. So let's explain this with a simple analogy. Imagine you are asked to write the number of numbers 1 to 100 on a piece of paper. You could write each number manually, but that will take forever and be very tedious. Instead, you would probably want to find a pattern or system to make it easier. That's exactly what loops do in programming. They execute a piece of code repeatedly based on a condition or set of conditions. Instead of writing the same code over and over, you write it once and let the computer repeat it as many times needed. Loops are essential for performing repetitive tasks efficiently. Without loops, programming would be incredibly tedious, and many tasks would be practically impossible. So that's all about iterative statements. So let's move on to types of iterative statements. So there are mainly 3 types of iteration statements. We have the for loop, while loop, do while loop. So for the for loop, it depends when you know exactly how many times you want to repeat something. With the while loop, when you talk about the while loop, it depends when you want to repeat something as long as condition is true. The do while loop similar to the while loop, but always executes at least once. That's for the loops. So let's move on to for statement over. Let's move on to iterative statement. That's the while loop. The while statement, do statement while. We have the for statement. We have the for statement. That's for declaration, the for statement. So let's talk about the for statement. The for statement is used to iterate over a range of values or elements in a collection. It's likely telling the computer, do this task starting from here until you reach there and change by this amount each time. That's the work of the for statement. So as you all can see, let's move on to the this is a practical example of the for statement. We say the for statement, it deals with the collections, the range or values of elements in a collection. That's the work of the for statement. So these are practical examples as you all can see on the screen. So let's move on to the initial statement. The initial statement. That's this one once at the beginning, usually to set up a counter. That's the work of the initial statement. The loop condition, this is checked before each iteration. If true, the loop continues. Yes, that's the loop condition. condition. Okay, these are practical example of the loop condition. So that's it. So let's talk about the while loop. Said the while loops execute as long as specified condition evaluate is to true. So a while statement executes its controlled statement until its condition becomes false. So this practical example. That's the syntax for writing while loop. So let's move on to the infinite loop. So here are some interest. Here is some interesting thing you can think of. You can create a for loop that runs forever by omitting all three parts. That's the while in infinite loops. So a while statement is also useful for expressing a loop without an explicit termination condition. So that's the work of the word loop statement. So this is a diagram to show the while loop statement. It executes true or false statement, as you all can see. So this is a practical example here with the while loop statement. The while loop statement, as you all can see. Let's move on to the do while. So the do while statement, it's similar to while loop, but with one important difference. The condition checked after the loop body executes, not before. This means a do while loop always executes at least once, even if the condition is false from the beginning. Yes, so that's the do while loop. That's the syntax for writing a do while loop. As you all can see, these are some diagram to show the do while loop. So let me move on to the do while loop statement. These are all practical examples. So existing from loops. Let's talk about that. So we are saying if the condition of an iteration statement is omitted, the loop will not terminate unless the user explicitly exits it by a break, return, or got true, or some less obvious way, such as a call of exit. So let's move on to existing from loop. So when we talk about break out of that's the nearest enclosing switch statement or iteration statement. We use a break when we need to leave the loop body that's in the middle. So existing from loops, let's continue. The break statement is used for two purposes: to exit early from a loop, to skip the remainder of the switch structure. So as you all can see, these are some practical examples we can see on our screen existing from loops break. So this is a code for using the existing from loops break. As we said, to break statements for purposes that's to exit early from a loop, to skip the remainder of the switch structure. So let's continue. Okay, sometimes we don't want to exit the loop completely. We just want to get to the end of the loop body. So a continuous keeps the rest of the body of an iteration statement. So, so when executed in a loop, it keeps the remaining statement and proceeds with the next iteration of the loop. So as you can see, these are the codes for writing existing from loops. That's what I've coded on my code block. So let's move on to the next step. So the nested loops are loops inside other loops. This is a powerful concept that allows you to handle more complex repetitive tasks. So think of nested loops like the hand of a clock. The minute hand moves once, and the second hand moves 60 times. For each minute, there are 60 seconds. So that's the nested loops. So these are the syntax or an example of a nested loops. That's X, as you all can see on the screen. So these are all syntax for writing nested loops. So let's call it a day. This is the end of our lesson with programming C++. That's week 5. It's quite simple. So we didn't waste much time here, as I explained earlier. So I think we are done with our lesson.